Hey friends, this is Vidhan. Welcome you to my channel. Today we have a problem from December 2015, question number 40, booklet code B. From analog electronics. If the parameters y and x are related by y equal to log x, then the circuit that can be used to produce an output voltage V0 varying linearly with x. The question is, output for which circuit is linearly dependent on x? That means the question is, output of which circuit is a constant times x and x has a power of 1. This relation actually shows the linear dependence of V0 on x. And why shows the linear dependence? Because if you plot a graph of V0 and x, for any value of k you will find a straight line, and that's why they have linear dependence. So this is the output that we should expect, and this is for which circuit? This is the question. Now, even if these are the four options, but you must remember that each option is very important circuit. Each option is something that one must have knowledge about. So the first circuit is the standard integrator circuit. The second is the standard logarithmic amplifier circuit. The third is the anti-logarithmic amplifier circuit, and the fourth is the differentiator. All they are having negative feedback. See here, it is the negative feedback. That means a circuit from the output terminal goes to input terminal. Here also negative feedback, and here also negative feedback. All the circuits are non-linear operational amplifiers. Why the word non-linear? It is because of the reason that these circuits give us non-linear operation on the input. What does it mean? It means here the output is actually integration of the input, integration of y, and integration operation is non-linear operation. And here, since it is logarithmic amplifier, therefore the output is log of input, that means log of y. And logarithmic operation is non-linear operation. Here the output is anti-log of input, and anti-log is non-linear operation. And similarly, this is the differentiator circuit, and the output is derivative of the input, and derivative is non-linear operation. See one thing, that all the four circuits, what I am saying is for knowledge sake, all these four circuits are doing mathematical operations on the input, isn't it? So these are also called electronic mathematical circuits, because you can do mathematics electronically using these circuits. Here integration, logarithm, anti-logarithm, and here differentiation. Also remember that you find the operation, here the operation is integration of input, but also there is a gain, there is a scaling factor, because whenever you use operational amplifier there will be a gain. Okay, so here also it is the operation of logarithm on the input, but there is a gain. Here also there is a gain, so the output is gain times derivative of input, and here the output is a gain times anti-log of input. And we understand these circuits, thus all these circuits are non-linear operational amplifier circuits with negative feedbacks. And we also know that for integrator, in the feedback circuit there is a capacitor, and for differentiator, before the operational amplifier there is a capacitor, and there is a resistor in the feedback circuit, etc. In our last video we have talked about all these standard non-linear operational amplifier circuits. Now we have to find that for which circuit this relation holds. Now see here that each circuit is having input y, and y is what? Y is equal to log x, x given in the problem. So it is log x, log x, log x, and log x. Now just looking at the problem you can understand which is the right answer. This is the right answer, 3. Because here the output is anti-log of the input, and anti-log of input means log of x, y is log x, that means anti-log of log x, that means V output is equals to x, because anti-log of log of x is equals to x. This is what we know. And integration of log x finally if we find, then we are not going to get this kind of relation. And also if we find here the output is log of log x, then if we do log of log x, then we are not going to get this kind of relation finally. And similarly if we do derivative of log x, then we are not going to get this kind of relation. But from here we can get this kind of relation. What I am saying is, okay, let us draw the third circuit, that is the anti-logarithmic amplifier diode. Out input is y is equals to log x, and this is output, and there is a feedback circuit through a resistor, this is RF. Okay, what I told, what is the operation that this anti-logarithmic amplifier does? It does anti-log operation. That means V output is anti-log of input is y, and that means anti-log of x, because y is log x. And whenever there is anti-log of log of anything, it is that number or that variable, so it is x, so V output is x. Why I said anti-log of log of x is equals to x? It is because suppose you have a number, that number is, let us take a number 1873. If you find the log of this, you will get 3.2725. Now if you do anti-log of this number 3.2725, then what you get? You get 1873. You get the number. And what does it mean? It means, I'm writing it again, anti-log of 3.2725 is what? Log of 1873. That means anti-log of log of 1873 is equals to, I am writing this line, okay, because anti-log 3.2725 is log of 1873 is equals to 1873. That means anti-log of log of any number is the number itself, isn't it? And that is what we have done here. Okay, now one thing that one may ask about is that one may ask me a question that in my last video what I had told, for anti-logarithmic amplifier the standard output formula I had written as minus IS RF e to the power V input by Vt. Now one may ask me a question that here I have done the V output as the anti-log of input. This is just the basic operation. This suggests this kind of operation, but this is not the standard output formula. So one should have a question like this, that this is not the standard output formula. Actually this is the standard output formula for anti-logarithmic operational amplifier. And from here we cannot see any anti-logarithm term. We don't see any anti-log of V input. So is that really that from this standard formula we will finally have this kind of relation V naught equal to x or V naught equal to kx? Then we could say that yes, we have done the right thing. Otherwise we have done it from our own mind. So for that, let me tell you that this will also be true. From here if we go, we will also get it. How? V output is equals to minus is we know, reverse saturation current, Vt is thermal voltage, and reverse saturation current and thermal voltage are the constant terms because it is 26 millivolt at room temperature, and it also has a value of at room temperature. That means for the diode under some constant temperature, these things are constants. RF is also constant, it's a fixed resistance that we choose here. Okay, now this we could write as RF e to the power 1 by Vt into e to the power V in, isn't it? Now minus Is RF e to the power 1 by Vt into v to the power v in is what? Log of x. Now this term is a constant. This whole term is a constant. And log of x. Sorry, e to the power log of x. Why this term is constant? Because I just told you that Vt is a constant. So 1 by Vt is constant and E is also a constant number. It has a value of 2.72 something. So 2.72 power a constant is constant. This is a constant, this is a constant for the diode under certain circumstance. So this whole term is a constant k. And e to the power log x. So we have k e to the power log x. And we also include the negative sign within k. Is that okay? So finally we have v naught is equals to k times e to the power log x. And always you remember that e to the power a number, e to the power log of z, e to the power log of any number is equals to that number z. Now from here we find e to the power log of x is actually x. So finally we arrived at this situation. So this is quite similar to this. Since we have not written here the scaling factor and or the standard equation, and that is why we have not found any k, but here we have arrived at this situation. So this was the linear relationship between x and v naught. So right, directly from the concept of anti-log operation of this, or by using the standard output formula, the standard operation that in output we get, we can arrive at this situation relation. So we saw that for this circuit we have the output as linearly dependent on input. So this is the right circuit, anti-logarithm operational amplifier. Thank you. Answer is 3. Thank you.